Good morning, students. As we discuss the P block element, group number 15. Now, the next topic is phosphine. Formula is PH3. First of all, discuss about its preparation. Then, many methods are used for the preparation of phosphine. First one is by hydrolysis of metal phosphide. Metal phosphides, for example, Mg3P2 magnesium phosphide. When hydrolyzed, then this is a binary compound, and in this reaction always the metal form its hydroxide, that is MgOH twice, and non-metal form its hydride, PH3. It is a gas, hence evolved up. Another example, for example, Ca3P2 when hydrolyzed, it gives CaOH twice, that is metal form its hydroxide and non-metal form its hydride, isn't it? Similarly, taken one more example, that is aluminium phosphide when hydrolyzed, then aluminium form its hydroxide and phosphorus form its hydride. So this one is the first method for the preparation of phosphine. Now second, that is important, by heating phosphorus acid. Formula is H3PO3, phosphorus acid. So the reaction is H3PO3 when heated, then it gives phosphoric acid with phosphine. It is called as phosphorus acid. It is phosphoric acid, and this one is phosphine, which is a gas. Now next method, which is also an important method, okay, about this reaction, it is a disproportionation reaction. Proportionation reaction. Finding out the oxidation state of phosphorus, then here it is +3. Here if we calculate, then it is +5, and here it is -3. So if we see, then from phosphorus acid to phosphoric acid, oxidation state of phosphorus is increased, and increase in oxidation state it is called as oxidation. And from phosphorus acid to phosphine, decrease in oxidation state takes place, and decrease in oxidation state it is called as a reduction. This type of reaction is called as disproportionation reaction. Now the next method is by treating white phosphorus with aqueous alkali in an inert atmosphere. which is given by decreasing the percentage of oxygen, or we can say air, by due the presence of either carbon dioxide or coal gas. Reaction is P4 plus NaOH plus water. In inert atmosphere, it gives PH3, that is phosphine, and NaH2PO2. What was its name? Sodium hypophosphite. Again, it is also a disproportionation reaction, isn't it? Now, main point about this phosphine, that in pure state phosphine is not inflammable. It means it do not burn, but phosphine which produced above catches fire when exposed to air. Why this so? Due to presence of P2H4, that is diphosphine, as impurity with it. So, with phosphine in the above preparation, diphosphine is also prepared, which is present as impurity with phosphine. So to make it pure, what we do? So next one is the purification of phosphine. So next one is purification of PH3. So it is purified by dissolving first it into hydrogen iodide. Here phosphonium iodide, that is called as phosphonium iodide, is formed, which when treated with alkali gives pure phosphine. Okay, now let us understand it with the help of reactions. That first, this PH3 dissolve in HI from the mixture of phosphine and diphosphine. It gives phosphonium iodide, which is acidic in nature. Now, when this phosphonium iodide is treated with a strong base, it gives pure phosphine. It is in pure state with salt, sodium iodide and water. So this one is the purification of phosphine, as it is impure phosphine, that is pH3 with P2H4. What are their nature? Alone it is inflammable, not inflammable, but diphosphine is highly inflammable, that it readily catches fire when exposed to air, isn't it? Now next one, about the structure of phosphine. So we already discussed the structure of hydrides of group number 15. Same for phosphine. Its hybridization is sp3. It is sp3 hybridized molecule with trigonal pyramidal geometry. It is already discussed in case of ammonia. Okay. So next one, about the properties. Then first physical property for ammonia, for phosphine, that it is colorless, and physical state is a gas. Second one, telling about the odor or smell, then it has garlic or rotten fish like smell, isn't it? It is highly poisonous. This is one the poisonous gas. Now next one is, if we discuss about its density, then it is little heavier than, not too much, than air. Next one, now start the chemical properties. Then it is basic in nature, but it is a weak base. As it is a base, it reacts with acid to form salts. Here phosphonium iodide is formed. Okay. Now next one is about the combustion. Then pure phosphine is stable, as we discussed already that it is not inflammable. So pure pH3 is stable in air, but when heating at 423 Kelvin, it won in the presence of oxygen to give phosphoric acid. Reaction is pH3 plus O2 at 423 Kelvin temperature it gives H3PO4. Okay. Now the next property about same heating but at small but high temperature in the absence of air. So when pH3 is heated up to 713 Kelvin in the absence of air, then it decomposes. That is pH3 713 Kelvin, absence of air, it gives P4 and H2, isn't it? Next one is reaction with halogen. Halogen specifically we take it here, chlorine. Okay. Then phosphine when react with chlorine, then both the elements form their halides as PCl3 plus HCl. But when we taken here excess quantity of chlorine, then PCl5 is formed here, isn't it? Now next one is the important property, that is when phosphine react with metallic salt solutions, then metal from salt precipitate out. As their phosphides. Okay. Now the reaction, some reactions are, suppose we have calcium phosphide, as we have copper sulfate, and when it is treated with phosphine, now the metal form its phosphide, which one is precipitate out, okay, and it gives sulfuric acid. Taken more example, that is HgCl2 when treated with phosphine, then mercury form its phosphide with acid HCl. So these are all the chemical and physical property of phosphine. Now last one is the uses. Very important. Phosphine is used as home signal, which is given to the steamer for signaling danger points, where in sea and oceans. So what happened in this how it acts as Holmes signal. Then a container, okay, see or not, then a container having calcium phosphide and calcium phosphide and calcium carbide. Okay. Pierced and thrown into the sea. With water calcium phosphide gives when it is thrown into the sea or ocean, then calcium phosphide react with water. Calcium phosphide gives phosphine with diphosphine, that is P2H4, which catches fire in the presence of fire, acetylene, which is highly inflammable, start burning. Which is used as Holmes signal. So this one is the uses of phosphine, which is used as Holmes signal. Second one, which is also an important, it is used in production of smoke screen. So how this is also the same method, somewhat different, that shells, containers having calcium phosphides explodes, in which phosphine catches fire in the presence of air, and foam, smoke, or we can say clouds of P4O10. Okay, this is the smoke screen, which is due to the pentoxide of phosphorus. How it formed? By the action of oxygen at phosphine. So these are two uses of phosphine, as it is used as Holmes signal, or it is used in the production of smoke screen, where it used in the warships, isn't it? So phosphine is completed